All right, so in this video, we are asked to prove this. This is Bessel function. We are asked to prove that j subscript minus n of x is equal to minus 1 raised to power n j subscript n of x. Okay, now to prove this, first of all, we need to find, we know that j of n of x, sorry, jn of x is given as, let me tell you how to remember it. Just have the summation of any alphabet you like. Let me choose r starting from 0 to infinity of minus 1 raised to power the same r. Then you now have 1 over that same r factorial. Then I'll now have r plus n. Okay, r plus this n factorial. Then you now have x over 2. Then you now see this as r plus r will give you 2r, then plus n. So I'm going to have 2r plus n here. So that is how I remember it. That does not mean that is how it is, but if you do it this way, you will remember the formula. You know that this formula looks long. So if you don't do it this way, you will not remember it. So another way you can write this formula is to say that you should remember that the gamma function of r plus n plus 1 is the same thing as saying, if it is plus 1, it's the same thing as saying just remove that 1. You now have r plus n, then you now have factorial. So this one can be replaced with this one. So I will now have that the jn of x is given as the summation of r starting from 0 to infinity of minus 1 raised to power r, then 1 over r factorial, the gamma function of r plus n plus 1. Okay, then I'm having x over 2, and then 2r plus n here. Okay, so I've gotten for jn. So let's check jn minus 1. So j subscript n minus n here of x is equal to the summation of r starting from 0 to infinity. That means anywhere I see n in this equation, I'll change it to minus n. So I'll have minus 1 raised to power r, 1 over r factorial, the gamma function of r minus n plus 1. You see that I'm putting minus n, changing it. So in bracket of x over 2, then I'm having 2r plus n. Okay? So having this, just the next thing you're going to do is you tell them to choose any other alphabet. Just tell them to change r to be n plus k. Okay, choose any alphabet you like. So that means anywhere I see n in this equation now, I'll put it as what? N plus k. So I'm going to have j of minus n of x is equal to minus 1 raised to power. I'm seeing r here, so I'll put it as n plus k. So I'm having n plus k, then 1 over, I'm seeing r again, I'll put it as what? N plus k all factorial. Okay, all factorial, then the gamma function of, I'm seeing n r here, so this is going to be n plus k representing this one, then minus n again, then plus 1. So if you look at this, n minus n will cancel, so I'm left with k plus 1. So this is the gamma function of k plus 1. Okay, then I'm having x over 2 here. Then to replace, I have that this is 2r plus n. That is 2 into, don't forget that my r is now n plus k. So n plus k, then plus n. So this time this will give you 2n plus 2k, then plus n. Is it plus n or minus n? Sorry, it should be minus, because here I said that anywhere you see n here, change it to minus. So this particular one is supposed to be minus. Okay, because I said anywhere you see n here, change it to minus n. So it's going to be minus n, not plus n. That's a mistake, sorry. So minus n. So this and this is gone. I'm left with what? 2k plus n. So this is what? 2k plus n. So having this now, we are almost done with what we are doing. So let me clean this. So you see that, let us separate this one. You know that according to indices, this is j minus n of x is equal to, separating this one, I have minus 1 raised to power n, then multiply by minus 1 raised to power k. Because according to indices, the reason we have multiplication is, the reason I have this addition is because of multiplication. When the base are the same thing. That is that a raised to power n multiplied by a raised to power m will give us a raised to power m plus n, or n plus m, anyone you like. That is indices for you. So I still have 1 over. Now, do you remember that this one is still the same thing as saying the gamma function of n plus k plus 1? according to this. And then this one is something as saying k factorial. Yes, then I'm left with what? X over 2, then raised to power 2k plus n. So having this now, you will see that, oh, sorry, I forgot our summation. There is summation here, please. There is summation here where r is starting from 0 to infinity. So don't forget the summation. So I'm going to have that this is now the summation of what? Uh, r starting from 0 to infinity. Okay, so having this now, you will see that this is now j minus n of x will now be the summation of this one can come to the back. I can have minus 1 raised to power n to be at the back. We'll now have the summation, and then I'm left with minus 1 raised to power k, 1 over k factorial first, arrangement is the gamma function of n plus k plus 1. Then I'm now having x over 2 raised to power the same 2k plus n. And if you look at this thing very well, this is something as saying minus 1 n, the gamma function jn of x, because this look like this. So that is just that, and it is now proved that j minus n of x is equal to this. Proved. Very, very simple. So we're going to prove the second one. We have just two proofs here. We're going to do the second one now. Okay? Permit me to clean here. So we'll do the second proof. Okay. So to do the second proof, this second proof is a recurrence formula. Okay? Yeah. Recurrence formula. Recurrence formula. Okay? And recurrence formula say that, wait, let me just close this because of noise. Okay. The recurrence formula say that x j prime n is equal to what? N j n minus x j n plus 1. Okay. Now, having this, we should remember our formula again. We should remember a formula that said that j, we want to prove this. We want to prove that this is equal to this. So first of all, let us get Jn. And our Jn is giving us what? Don't forget that the summation of what? R starting from 0 to infinity of minus 1 raised to power r, then 1 over, 1 raised to power r, then 1 over that same r factorial. Then I will now have the gamma function of r plus n plus 1. Okay? Then I told you that how to remember what will now be here, s over 2. I'm going to have r plus n. That is what? 2r plus n. That is how I remember the formula. So the next thing we're going to do is to differentiate, because this one is differentiated. If I differentiate, j prime of n is equal to, and I'm differentiating with respect to x. I'm differentiating with respect to x. So everything that does not have x is a constant. So from here to here, they are all constants. So I'm going to have the summation of r starting from 0 to infinity of minus 1 raised to power r, 1 over r factorial, the gamma function of r plus n plus 1. Everything here is a constant. So we are differentiating this, and this is a chain rule. And chain rule said you differentiate the bracket, then you differentiate everything. So if I differentiate this bracket, I'm going to have 1 over 2. If I differentiate the bracket. Now, differentiation of this thing is multiply by the power, remove 1 from the power. So I'm going to have 2r plus n. Then I'm going to have x over 2 raised to power 2r plus n plus 1. Okay? So this is how it's going to look like. So the next thing we're going to do here is to separate them. We're going to separate the 2r, and then we're going to separate the n. But before that, this is multiplied by x. So let us multiply everything here by x and see what we are going to have. Okay, sorry, it's not plus. We are removing 1 from the power, so it's going to be minus. We are removing 1 from the power, it's going to be minus. So we're going to multiply by x. If I multiply by x, I'm going to have that x j prime of n is giving us the summation of r starting from 0 to infinity of minus 1 raised to power r, then okay, want to multiply by x. Okay, before that, let us separate before we multiply by x so that it will be easier. I hope you know that these two people are in the bracket. These two people are in the bracket. Or rather, let me keep it the way you understand. Let me write this one first before the bracket so that it will not confuse you. So we are going to have that this is x over 2 raised to power 2r plus n minus 1. Okay, then I'm going to have in bracket of what? 2r plus n. Okay? So now, having this now, we can separate them. Then multiply by x. Or multiply by x and separate them. Anyone you like. Okay, let's multiply by x first. X, j, n prime will now be x, the summation of r, starting from 0 to infinity, of minus 1 raised to power r, 1 over r factorial, the gamma function of r plus n plus 1 into 1 over 2. Then I'm having into x over 2. Then I'm having 2r plus n minus 1. Then into 2r plus n. Okay? So, having this now, let us separate. If we separate, I'm going to have that, if you separate, I'm going to have that this is, okay, let us separate. If we separate the 2r and the n, that is what we want to separate so that the 2r can stay alone and then the n can stay alone. I think, okay. So if you separate, I'm going to have that x, j, n prime will now be separating now is this x with everybody will multiply 2r and this x with everybody will multiply n. So I'm going to have that this will now be x, the summation of r starting from 0 to infinity of minus 1 raised to power r, then 2r first. So let me have it on top here. 2r all over r factorial, the gamma function of r plus n plus 1. Okay? Then I'm having 1 over 2 here. Then I'm having x over 2. Then I'm having, okay. This time this is giving us x over 2. So let's have that this time this is giving us x over 2. So x over 2, 2r plus n minus 1. Okay, so have I multiplied everybody? Yes. So it's going to be plus. So the same thing again, but be multiplied by n. So I'm going to have n, the summation of r starting from 0 to infinity of minus 1 raised to power r, then 2r on top. Sorry, n. There's no 2r on top. Rather, I'm going to have 1 over. So it's going to be 1 over because this n is here. Why the 2r is on top of here. Anyhow you arrange it. But so I'm having a 1 over 1 over r factorial. Then the gamma function of r plus n plus 1. Then I'm going to have x over 2 again, then x over 2, then raised power 2r plus n minus 1. So according to indices, you see that this thing is raised to power 1 and it will take care of the minus 1 here. So according to indices, because it's going to be x over 2 all raised to power 2r plus n minus 1 plus 1. So the plus 1 is because of raised to power 1 here. So it's going to take care of this. So this one will be out. So this thing is taking care of the minus 1 here. So this thing is taking care of the minus 1 here. So we are left with, let me clean the board. So we are left with, so if we are left with this, you see that obviously that that this one means n, the gamma function of n. Because if you look at this now, you see that everything here is the same thing here. Look at it very well. From here, everything here is the same thing as everything here. So I am left with, okay? Okay, I am left with that x j n prime will now be equal to. So let me first of all write this one. Now this one means n j n, then plus the summation of r starting from 0 to infinity of minus 1 raised to power r, then I have 2r on top all over r factorial, then gamma function of r plus n plus 1, then I'm left with x over 2 raised to power 2r plus n. Okay? So we're looking for the gamma function of n plus 1. So we're looking for the gamma function of n plus 1. So how do we get that now? Okay? So what if we put um, problem? Where is the problem now? Okay. Now, instead of multiplying this so that this will be out, maybe we'll leave it that way because we need the x at the back there. We need the x at the back there. So since we need the x at the back there, let's leave this one the same way. So because you'll be doing something that will require you to. So please permit me to start from here again. Let me explain from here again so that it will be easier for us. Okay. So now we want to open this bracket. Since we want to open the bracket, we want this thing to look like this. So for us to look like this, the first thing we're going to do is, let me multiply the n first. So I'm going to have n, then inside the n now, this x will times this over 2. So I'm going to have that this is the summation of r starting from 0 to infinity of minus 1 raised to power r, 1 over r factorial, the gamma function of r plus n plus 1, okay? Then this x is timesing this to give us x over 2. Then I'm having this one to be x over 2, then 2r plus n minus 1. So you see that I have multiplied n with all these people. So the next thing I need to do is to multiply 2r with all these people. And if you look at this, see that x is at the back here. So I don't need this x now to come and multiply here when I want to do for the 2r. So it's going to look like this. It's going to be plus. I will leave the x at the back. The summation of r starting from 0 to infinity of I'm having here to be minus 1 raised to power r. Then on top of this place is what? 2r will come on top of this place. So I'm having 2r here all over r factorial, r plus n plus 1, gamma function of r plus n plus 1, okay? Then I'm having 1 over 2 here. I'm having 1 over 2 here. Then am I done with everything? Okay, then I'm having x over 2 raised to power 2r plus n minus 1. So obviously 2 will take care of the 2 here. Then what again? 2 will take care of the 2 here. So I'm now left with, where is my dust? So I'm now left with, look at this very well. I'm now left with, let me draw my line. I'm now left with j prime of n will now be equal to. Now, if you look at this place now, you see that this is raised power 1, like I said before. So everything here is taking care of the minus 1 here. So I'm left with this, n this. And if you look at this very well, see that I'm left here with n the gamma n the summation of r starting from 0 to infinity of minus 1 raised to power r, then 1 over r factorial, then the gamma function of r plus n plus 1, then I'm left with x over 2 here, then raised power 2r plus n. So everything here is the same thing as this formula. So here will now be n d j n, n j n. Okay, so I still have my plus. I still have my plus. So here is giving me x, the summation of r starting from 0 to infinity of minus 1 raised to power r. Then I'm having on top of this place r over r factorial, the gamma function of r plus n plus 1. Then this is gone. So I'm left with what? X over 2 raised to power 2r plus n minus 1. Okay? So having this thing, so the next thing we're going to say is we'll say, let us put r minus 1 to be equal to s. Okay? Any problem here? Okay. Now, first of all, let us find way to cancel this r. For us to cancel this r, do you know that r factorial is the same as saying r into r minus 1 factorial? They are the same thing. So since they are the same thing, according to factorial formula, so we're going to have that. So to cancel that r on top, I'm going to have that x j prime of n is equal to nj of n plus x, the summation of r, starting from 0 to infinity of minus 1 raised power r. I have r on top all over. This thing is simply saying r into r minus 1 factorial. Then I'm having what? R plus n plus 1. Then I'm having x over 2 raised to power 2r plus n minus 1. So this r is now taking care of this r. So I am now left with n j of n plus x, the summation of r starting from 0 to infinity of minus 1 raised to power r, then 1 over r minus 1, then this r plus n plus 1, okay? Then I'm now having x over 2, then 2r plus n minus 1. Okay, so now the problem here is now r minus 1. So let's say, let r minus 1 be equal to anything at all. Let's choose any number. Let us choose k. Have I used k before here? No. So let us choose k. We can say let k be equal to that r minus 1. So if k is equal to r minus 1, I'm going to be having, so anywhere I see r minus 1, I'll put k. So that means anywhere I see r, I'll put this one coming here, I'll put k plus 1. So anywhere I see r, I'll put k plus 1. So anywhere I see r minus 1, I'll put k. So this is now that x, j, n prime will now be what? N, j, n plus, I have x here, the summation of r starting from 0. Okay, let me say the r is k plus 1 anyway. So let's say k plus 1, k plus 1, k plus 1 starting from 0 to infinity of minus 1 raised to power, minus 1 raised to power. This is my r. So r is something as k plus 1. So k plus 1. Okay, you are getting it. So 1 over. So this is r minus 1, and r minus 1 is k. So I have k factorial. The factorial function of um, this is k plus 1 plus n plus this. So that is k plus 2. Okay, so it's going to be k plus 2 there. Yeah, so it's going to be k plus 2. Here it will now be k plus n plus 2. I hope you understood that. So I'm going to have that I'm left with what? X over 2 into. Now this is 2 into k plus 1, then plus n minus 1. So this will give you 2k plus 2 plus n minus 1. So this and this will give you plus 1. So I'm left with 2k plus n plus 1. Okay? 2k plus n plus 1. That is what I have there. Okay? 2k plus n plus 1. Is that correct? Okay? So, what's the next thing we are going to do now? Let us check what we are going to do. Okay. So now, if you look at this very well, remember what we are trying to get is for n plus 1. So that means, how do I get that now? We want jn plus 1. So let us see how we put this. So this is going to be n, this n plus x, the summation of k plus 0. I can just say k starting from 0 because k is equal to minus 1, and minus 1 will not work. So starting from 0 will not work. 0 to this, you now have minus 1 raised to power k, then minus 1 raised to power 1, separating this one. Okay, then I'm having 1 over k factorial, then k factorial, then I'm having, yes, k factorial, then I'm having the gamma function of k, then I'm having plus n plus 1, then plus 1. Okay? And then into x over 2, then the same thing here, 2k, then plus n plus 1. So if you compare this now, then minus 1 raised power this will make here to be minus. So I'm left with nj of n minus. Then if you look at this now, you will now see that, let's just put the x here. So this is obviously j n plus 1, because if you look at my formula here, if I have n here, I'm having n here. That is when n will come here. So if I have n plus 1 here, I'm having n plus 1. That is when n plus 1 will come here. So, and it is now proved. So thank you very much for watching. If there's any place you did not get, please rewind it and watch it 10 times, and then share to your friends or tell us in the comment section, and then we'll tell you what to do. Bye-bye.